Okay. On behalf of the weekly webinar series hosted by IEEE Malabar Subsection in association with IEEE Malabar Hub, I extend a warm welcome to each one of you gathered here for the 57th webinar of the series organized jointly with IEEE Student Branch, KMCT College of Engineering on the topic Product Development in Microservices and Cloud. Today, we are honored to have with us Mr. Roshik Mohamed, Head of Engineering, Amdocs Development Center, Pune. Mr. Roshik is a visionary leader with an experience spanning more than 20 years in aligning innovative technology strategy with business needs to maximize profitability and drive organizational growth. He also has an international experience over 13 years by actively working with companies, clients, and vendors, and also manage teams across the globe. He's an MTech holder with a master's degree in management from Harvard University. He also has to his credit of building many teams from scratch in latest technology and is an active member in many international forums. With huge respect and admiration, let me now invite Mr. Roshik Mohamed to start the session. Over to you, sir.
Thanks, Priyanka. So Amita had reached out to me a few days back, and by the way, she's my cousin, and it was a huge privilege for me because my home is around 5 kilometers away from KMCT. So this session is very special, and I heard a lot about what you all are doing, and Sabi sir and the team. It's really impressive to have such an initiative and to have 57th episode. It's really impressive. Now, without further ado, I would like to once again, acknowledge the fact that for me personally, this is a great privilege, to be part of this IEEE KMCT College of Engineering Students Branch initiative. So thank you so much for the opportunity. Let me share my screen, and then we'll dive into the subject directly. Please let me know when you're able to see my screen.
Yes, we are able to.
Okay, perfect. So today we will talk about, I just kept the agenda very simple. It's just cloud and microservices. Since this is being conducted or led by the college, I thought I'll keep it basic, simple. Since students are going to be there, but since there are going to be a few senior colleagues also, I'll touch upon some of the additional complex aspects of the development if time permits. So before getting into the real talking about cloud or microservices, the very first thing I want to tell you all, in today's world, in technology world, there is an explosion of tools and technologies. So literally, you take any phase of software development, testing, deployment, production management, it's unbelievable. Every 2 months, 3 months, we have new set of tools coming in, and better set of tools coming in. And there are companies like Netflix and Spotify doing amazing stuff, putting code into production pretty much every day, where many companies are struggling even to put code in a monthly or even quarterly basis. So the very first thing I want to tell all the students and aspiring IT folks is that don't panic. Believe me, there's no one in this world, literally no one in this world who knows everything about the technology world. Okay, not even Amazon employees. I was there for 13 years in the US. I've met Amazon. My colleagues' friends are working there, Google and all places. There's no single person who knows everything about what's happening in a particular company. So the most important thing is try to understand 1, 2 small things at a time. And then when you get into the industry, when you start working on those things, understand the basics, and then you'll be able to build on top of that. So I might, during my conversation, I will try to keep it very simple. I'll try to, have some layman examples. But if there are some jargons coming out of my mouth, please keep a note. We'll have some time for the questions towards the end. I was debating a lot in my mind. The subject said, development in microservices and cloud. There is a reason for that, because we first develop the code in microservices and deploy into the cloud. But still, I thought for this session, I will talk first about the cloud and then about microservices. And there's a reason for that. So over the course of the session, you will know that. Now, cloud computing, I'm sure most of you have heard. I will have few slides for the definitions, but then of course, just for us to take through, I'll give some simple examples also. Cloud computing is basically on-demand delivery of IT resources. And it is through the internet. As far as you have an internet and a credit card, you're good to go. You can buy literally any flavor of the servers, storage, or any such IT resources that you need to run very complex applications within few minutes, configure within few minutes, and you are good to go and can be accessed across the globe. And it is a shared pool of configurable computing resources. So I'm going back to this slide so that you're not reading right now. So I just want to give you an example. If this was 20, or 15, 20 years back, when I started my career, if we, myself or a couple of friends want to start a company, it was very difficult. Why? Because very first thing, let's say you have a desktop, you're writing code, and you've built an application, web application. Now, how will you host this application so that users can use it? You need to first order for a server, a hardware. And that ordering, the process during those times, it used to take like anywhere between 2 to 3 months. So you need to first of all size the hardware. You need this much capacity. Then you put the order. Then it comes by mail or someone delivers it. And then you need to find a place in your office or in your home, a corner where you can put that stuff at the server. And then you deploy into that. And then you still cannot have this accessed by the people in the US and the in the Europe, because the bandwidth and the connectivity and all these things are issue. Second thing, let's say you are like the friends are starting a business, a food delivery app or something, or something like that. And if let's say you are expecting, for the simplicity of our discussion, I'll keep the numbers very small. Let's say you're expecting 1,000 customers per day. Okay, and for that you need to at least buy a server which will support, let's say 1,200 or to keep it simple, let's say at least 1,000 transactions per day. You need to buy a server. Now you bought that server. Now you are starting your business. Day one, you might have 5 customers, you might have 10 customers, but keep in mind you have already paid for the hardware for the entire 1,000 customers. So you have wasted your money there, because you're not getting any revenue out of it, but you invested your hardware for 1,000 customers. Now, as you go first month, second month, third month, let's say you reached up to 800 customers. Now you're not going to stop your business and at the 1,000 and say no more growth. By the time you're 800, you need to buy the next server. Why? Because when you hit 1,000 and 1,000 first customer try to purchase, your system will go down because your server that you bought does not have a capacity. So by the time you're 800, 850, depending on how many days it will take the server to reach your home or office, and what is the rate of the transaction or rate of the customer increase in your application, you need to already invest in the hardware, future hardware already right now. So now you have another hardware coming into your house. Now you have to pay the rent, or if it's office, or even if it's house, get congested, you need to have a larger space. So you are investing in infrastructure, you're investing in servers, which you are not going to use for next, let's say 6 months, because you're buying it for your future business. What changed? Fast forward today's world. 2 friends, 3 friends, you want to start a business, you built a very complex application, you have your laptop, you built it, you want to deploy, all you need is internet connection and credit card. You go to Amazon or Google or Microsoft or any such cloud provider, go to the website, register, few click of buttons, you can select what kind of computing operating system you need, what computing power you need, whether you need your application to be running only in the daytime to support US, only in the night time because the servers are cheaper than to support the US customers, or do you want to also do some batch wise, like if monthly, if you want to generate the bills, you want to do only it in the off time. So all these configuration within a few minutes you can select, click of a button, you are up and running. Now when you deep dive into the cloud computing world, you have different zones, availability zones. Now, when you talk about Amazon, Amazon has servers in US, in Europe, in India, and all these places. Now you can decide when you deploy your application, you can decide when you want to have an instance in US, availability zone. What does that mean? When you have your server and you're not, in the past, you had to find someone in the US who can keep your server there and configure, etc. Today, nothing of that's all taken care. You just purchase, configure your server, or there is a portion of the Amazon server working for you, and you pay as you go. You're not investing thousands of dollars to start with. You try it out the market, and if the transaction customers are increasing, again, online, you can just keep increasing your, the computing power and expand your business. So this is all about cloud computing. And of course, I will touch in the later stage, I will talk about how this is helping corporate companies like us, as opposed to startups, which is like relatively less complex applications, and we deal with much more complex applications. So I will touch upon that, how that's changing. So this is at a high level cloud computing. And again, Priyanka, I don't know if we want to allow questions during the session or towards the end. Feel free, I'm okay for both options.
So we can ask towards the end.
Okay, sure. So moving on, so I'm not going to definition and bore you. I'm sure you can get it in Google, but still for the completion of the deck, I wanted to have this here. So benefits, IT agility. Basically, you don't need to worry about, as a software developer or a software leader, I don't need to worry about all these hardware and the electricity used and the server space and real estate and all those. I can focus my full creativity and energy on really creating features for the customer in the software, like the product side of things, and all the other things are kind of outsourced, and it's on demand available. So this is the IT agility part. We can move much faster. Cost optimization, I explained you already in the past how we had to invest upfront the capex cost, and today we just need to we can test the market. If we are getting customers, we can always increase our investment. So this is one very interesting opportunity for the youngsters to start business. And the business agility, basically, I said go global in minutes. Like you tested in 1-2 markets, or a particular state in one of the in the US. Let's say you tested in one state and you want to expand, or in the Europe you tested in one country and you want to expand. All those options are available without any, not even traveling there. You can sit at your home and do this. And just from a statistics perspective, in the corporate world, especially for the folks who are looking to get into the IT world, or who are there already in the IT world, in next 5 to 10 years, the IT spend is going to be huge in cloud. So some of the companies, IT spend itself, when I say IT spend, overall IT spend itself can be stagnant or very narrow growth in some companies, because of course they are always looking for efficiency. But within that spend, the expense on cloud is going to be much higher, because a lot of companies, or every customer that we are talking to, everybody has a cloud strategy. So next to 5-10 years, if you are into cloud, I can guarantee you will have a job. Now we'll talk about some certifications towards the end, and how to get ready, etc. So just to give you a little bit of everyday items around you, the base offer, the bottommost layer is the infrastructure as a service, AWS Elastic Compute, Microsoft Azure, Google Cloud Compute. So these are the real the infrastructure, the machines, the databases, all those basic electrical and electronic things that you need, the data center needs that you have. This is available in IaaS as a service. Then it's the platform as a service. So on top of cloud, a lot of platforms have been created by various companies, by the cloud providers and also other external vendors. I've written a few examples here. And the third one, the end user, it's a software as a service. I'm sure all of you are familiar. The Gmail, Salesforce CRM, Office 365, Google Docs. So all these are again on top of the cloud. So the beauty is that more and more customer gets onboarded on Gmail, for example. Unlike the olden days, Google need not go and physically now set up anything. Just auto scale. They have set it up as auto scale, and as and when the traffic will increase, automatically the servers will get used for this each of these applications. Moving on, AWS is the leading cloud vendor today. Microsoft Azure is catching up very closely, then Google Cloud, and there are many other cloud vendors as well. The reason for this slide is whoever is interested in learning cloud, of course, if you read through Google, there's a lot of knowledge, a lot of awesome videos. How, for example, at AWS has put the cables under the sea. The Amazon has put the cables under the sea. It's very interesting video. If you just Google, you can see how they have optimized even the energy loss or transmission loss when you have big underwater sea cables as there. And also you can imagine they cannot keep it high because of the ships passing by, whereas when you keep it lower on the sea bench, it's more data loss. So it's not just software or IT information that has gone in to building all this stuff. So there's a lot of electrical engineering, mechanical engineering. It's amazing. There's a whole world out there. So if you are interested and passionate about technology, just go and subscribe for a certification. This is what I did when a few years back, when the cloud was buzz and new in the IT market. I took up an AWS architect certification, not the basic one, but to take the tougher one. So I took the AWS. I took it as a challenge, and I told my wife next few days, I'll need some extra time outside of work to get this done. And I took a 2 months break from few other responsibilities, and I focused on my certification. 2 months, of course, you guys are, if you're students, you have your own curriculum to go through, and others who are in working, you have your day-to-day job. So it's extremely important for us personally. Like we are always asked to invest in health, same way for career, we are required to invest in our learning and upskilling. So I would recommend to take a certification, pick any of those, but I'm preferring AWS because I did that, and plus, it's the leading one. So the opportunities are more there. So once you take that such a challenge, and you take 2 months, let's say, and you do that end-to-end certification, you get a very good view of what is out there, what are the different options that is there in the cloud, even in the machine learning area, in the IoT area, etc. And then you can choose. If you're specifically interested in a particular domain or particular area, then you can, of course, deep dive, and you can even look for job in that specific area to, excel in that space. Moving on, microservices. So I'm just pausing here for a minute, just to kind of recap. Like I told before, AWS or the cloud as such is mainly a deployment option. Okay, of course, they give a lot of amazing tools on top to build applications, to deploy applications, to do a modeling of machine learning, to do video to voice conversion. Alexa, I'm sure you all know Alexa. You have, if you do the certification, you can even program Alexa, like if you want some answers to be customized, or if you want to add additional question answers, it can be done. You can take notes, class notes, feed it to Alexa, it will read out for you. A lot of interesting everyday applications are there. So this is basically the platform where we deploy stuff and we run the stuff. And it's very important to learn, because this is where the industry is going. This is where the world is going. Now, microservices is a development approach. If you all know waterfall model, in the past few years back, when there was a requirement, let's say we are talking about a new, let's Infosys, or even for companies like us, Amdocs, the IT companies, we go to the customer, we talk to them, understand their problem. It's like a average 6-month sales cycle. And at the end of the sales cycle, we get a Word doc or whatever PDF with a long list of requirements. And then there is like a 3 months, 4 months, or even 6 months solutioning. There's a lot of solution people's architects designing how the system should behave, etc. And then after 6 months, you start the development. The development is 6 to 8 months process. And then after that, you have a testing phase, and then you deploy or deliver it to the customer. So bottom line, from the time you started the sale to solution to development to deployment, it's generally 1 to 1.5 to 2 years, sometimes even more, when it comes to migrating thousands or millions of customers from one platform to other platform, like we had in Idea, Vodafone merge. There's a lot of customers to be migrated from one platform to other. So if such things are there, then it's 5-year project. This was the olden day. And each file, when for the folks who are familiar with the the software, the file, you have like thousands of lines of code. Okay, literally thousands of lines of code. And if you change one line of code somewhere, you don't know what all flows you are going to impact. You might be fixing an defect, but you might be breaking many other. And this is where the new world of microservices has come into picture. And pretty much every industry is moving towards microservices. And if you are interested to come to IT world, this is another basic concept that you should learn. What's microservices? It's basically a highly decoupled service that work together, which means in the past you had thousands of lines of code in one file, but today you have small features that can be decoupled and managed separately. So just to give you an example, let's talk about an online portal where dresses are sold, or online portal where you go and purchase stuff and order stuff. So let's talk about the cart. The cart where you add your products. You add the first product, you add the second. After the review and everything, you add first cart, then you add second product to the cart, and then you check out the cart, right? So that cart itself, that small cart, that itself is like a small domain or a subdomain, I should say. And within that, small applications or the functions can be one microservice. So for example, when you check out, you are going to make a payment to your credit card. There's a call that's going. So that can be a separate microservices. The payment itself can be a separate microservices, the payment gateway. So now what is the benefit of having this decoupled services separate? Because in the past, if I have a change in a functionality where I want to now enable the user to use Google Pay, as a medium of payment in my website. In the past, when I changed such a thing, when I enabled Google Pay payment in my website, it was a big deal, because I don't know what else I broke, because the file is same. I have 5,000 lines of code. Let's say it has multiple features. It has credit card payment, Visa, MasterCard, Paytm, and all those. So if I change some code for Google, maybe I will break something else, because it's all intermingled code. Whereas nowadays, this piece of code is completely different. I can give it to a graduate who is joining from college, and I can ask him to code this integration with the Google Pay, and I'll assign one of the senior tester who will give him all the test cases. Let's say 10 test cases. So this graduate or this fresher who's joining from the college, let's say in 2 months, 3 months, get all training on the technology, and I can trust him, because I know that whatever code he has done, as far as he's clearing that 10 test cases, I can put that code into production. I can give it to customer, because his code is not going to interact or change the behavior of other code that we have built over the last many years. And this is what the decoupling is all about. And this is the beauty of microservices. Moving on to the next slide. Just to give you a few benefits: faster time to market and business agility. Like I said, in the past, in my career back in 2002, 2003, even before, when I hired people from outside, it used to take an easy 6 to 8 months for a person to become or come to a level where I can confidently give him something and forget about it. Because it literally takes few months, 2-3 months to even learn the basic technology. Then it will take few another months to learn the application. Then he or she will need some hands-on experience to try it out, make some mistakes, learn from mistakes, etc. And there is always someone, a team lead or someone, to be there to support them, to review their code, to test their code, etc. And in today's world with microservices, I'm so confident that when the graduates join from college, today I have 1 month generic training and another month my unit training, and that's the third month onwards. Even the new joiners are productive, literally productive. So this is the beauty of decoupling and microservices. Market trend: our customers demand MS, and this is why I'm telling all of you that you also, if you're not into microservices yet, I think you should look up in Google and at least learn about what is microservices, what are the cross-cutting concerns in microservices. Basic paradigm of microservices development. It's awesome to learn that, and I would recommend strongly to do that. So like I said, companies like ours, even if we don't want to, there's no choice, because our customers want that. Unless we do that, we don't get a deal, we don't get a project. So cost reduction, a lot of open source. So in the past, there were a lot of custom solutions that we had to build, right? Because to integrate, let's say you're starting a particular telecom company, let's say, and you want a billing application, you want a ordering application, you want a reconciliation application. All this had to be either built, or most of the times built, or it has to be purchased from huge, large vendors, and it was very expensive. And nowadays, because of the microservices, I can decide as a company what features I will build internally and what features I want to give externally. And just 1 second, my son is here. Just extremely sorry. There was an emergency for my son. Wife and daughter has gone out, so sorry about that interruption. We talked about market trend, cost reduction. We talked about yeah. So cost reduction. So in the past, it was like you had to buy COD software, which was very hectic, hefty, heavy. But today the beauty is that I can decide what functions I want to build and what functions I want to outsource. Because as you all know, there are so many startups out there in the market who are doing some specific things, Internet of Things, IoT. If you want things to be measured from different devices, all these watches and other devices that are coming up, you might not have the appetite and the time to build those solutions in-house. The beauty is that you tie up with one of the startups or one of the vendors. They come with their solution with Microservice solution. Ours is also Microservice, so it's very easy to plug and play. And there's a lot of open source solutions out there, which is very less expensive also for us to try and use and see if it's working, etc. You are not marrying into a huge contract, 5-year deal, 10-year deal with millions of dollars. And this is the beauty. Better quality by better testability. I explained you the example of giving fresher to a particular module to connect with Google Pay. It's very easy for me to give it to someone, get it tested, get it deployed, and not worrying about I'm breaking something that is already in production. Full dev to pipeline automation. This is more around DevOps line. It's a different topic altogether. I have put a slide towards the end. If we have time, we will take it up. But otherwise, it's more about DevOps. How things have changed in the software world. Where in the past it used to be 6 months solution, 6 months development, etc. Today, companies have option to decide and push the code to production on a daily basis. Like I said, Google, Amazon, and all are pushing features every day. You might log into Facebook today, and you might see a few things. Tomorrow you log in, you have a different feature. Day after tomorrow you log in, you might see a different feature. And they do it in regionally. They might open for a few set of customers so that it gets tested, get the feedback, how it's working, etc. Then expand to others. So all this is possible because of the automation that is there in today's world with all the DevOps tools that we have. Cloud native. Microservice cloud native is nothing but an application that is cloud ready. So what is cloud ready or what is cloud native? So today, let's say in the past you have a application which is a monolithic, thousands of code, everything is being done in one application, ordering, billing, everything is done in one application. So if you want to, let's say you in the daytime you get orders, let's say 1,000 orders you get every day morning. And let's talk about a telecom company, Airtel. Airtel gets everyday morning orders and also get transactions because we all make the calls, etc. But then when it comes to bill, of course the transactions are created, but bill generation is monthly. Monthly for me, I get monthly bill. You get your monthly bill, but it's not everything on same day. It's not on 30th of the month. For me, I might get every month on 3rd of the month. It's called bill cycle day. For you, you might get 6th of the month every month. Someone else get 9th of the month. Why? Because the company is trying to share the load. Imagine generating or printing the bills for 100,000 customers, everything on end of the month. It's huge volume. Instead, if you split into 10 cycles, for example, 100,000 will just get divided into 10,000. So every night, if you do 10,000 bill, 10 days a month, you still bill, print 100,000 bills. So, and the beauty is that this bill printing need not happen during the daytime. So during the daytime, you have a lot of people making the calls. So your servers, your infrastructure of the IT is being used for that, for the ordering, for collecting the transaction, to connect your calls, etc. And in the night, while you all are sleeping, the same hardware can be used for bill generation. So this is the beauty, that you have if you have this ability to segregate your application. In the olden world, if you want to do this, you didn't have choice because you have one single application. Whether it is morning or night, you are still deploying, ordering, and billing all the functions. But today, in microservice world, during the daytime, you can deploy only the microservices that are ordering related, and in the night you can deploy only the billing related microservices. So this is what is cloud native is all about. So when you, let's say you have a Diwali sale, and as you all know, Diwali sale, you have huge increase in number of transactions that comes to the websites. Now in the olden world, you had to buy hundreds of servers and keep it ready and use it just for Diwali. After Diwali, all those servers are just sitting idle, right? Whereas today's world, even during Diwali, you know exactly what area you need to increase. It is ordering. Ordering is going to increase in those 3 days. So your beauty is that only that ordering microservices you can expand. You don't need to expand your billing microservice because it's not immediate, only that 3 days. The billing printing then can happen even the entire month. So that is load distributed. But this 1 or 2 or 3 days during the Diwali, the sale, for that you can just take your ordering microservices and then expand it out. You can deploy like hundreds of instances or thousands of instances. And this is where the cloud native is talking. Means your application is split into multiple features, and you can decide based on the business which feature you want to blow out into multiple instances so that it's available for the user to use. And in the olden days, when you go to a website, you see file not found, and sometimes 404 and all. These days we see that hardly, because it's always available. And in the cloud, there is an option to automatically scale up and scale down. You can configure that as the transaction hit the 90%. You can add, you can decide the block you want to add, 5 GB, 10 GB, whatever, and then it automatically get increased. And when the volume goes down, let's say 3 AM, 4 AM, if the traffic goes down, it automatically reduce also. So you are not paying for the hardware that you are not using. So this is cloud native, very important. So so when you are coming into application development, and even if you are going to do a startup, always keep in mind that when you do a development, keep the end in the mind. So you need to make sure that it's cloud native, so that even if you are not going to cloud right now, in future you will have option to go to cloud easily without rewriting your code. How much time do we still have 26 minutes, so let me continue. So now when I talk about microservices, I have to, I've taken examples, but still I want to mention this. So microservices, single function focused, which means when you write a microservice, again, like in the olden days, don't make mistake. Don't do 2 things in a microservice. Decide a single function, write a microservice for that. Maybe shipping, maybe payment, simple things, decide and then make the microservice. It should manage and hold its own data. In the sense, if you have a ordering microservices, that should have its own table in the database, and only this microservice will manipulate the data in that particular table. So if you guys are familiar into the development, in the olden days, if you remember, when we used to do the application, there's a database and there's a application layer, there's a database layer. Now the problem is there are multiple APIs that can touch the database, and the data gets corrupted, and investigation is so cumbersome because you don't have any trace of what made this corruption. And in today's world, we know that it has to go through only through microservices. We don't run any scripts in production as much as we can. And I should say, literally, we should not do it at all. And all the changes are going through the microservices, which means if I have to update a record, employee record or some other record, the updates are going through the microservice, which means I'm already having all the validations. So my data will not get corrupted. And this is the reason I want to make sure that for every microservices which is managing a single function, it is owning its data also. So if there is let's say you have a payroll application and it's having its own data, and there is a different one, a specific salary module. And if salary module has to get this data, it has to go through one of the services exposed by payroll module. Easy and fast to scale. I explained you already. You might have some functions that is needed, for example, ordering in case of Diwali. So it's very easy for you to scale that. Resilient and flexible. Again, since it is smaller bit, it's very easy for us to kind of make sure that it's all automated and all the automation test cases are built around it, and it is very resilient. We are not someone doing some mistake somewhere else in the application is not going to impact this. Deployed independently. We'll talk about deployment if time permits towards end. It's deployed independently, unlike the olden world where we deploy a huge application. And then infrastructure automation, the DevOps part that I talked about. And if in case time permits, we'll talk about that also. In the microservice world, it's much easy to automate the infrastructure which is required for the microservices. This is the attributes of microservice. I have a couple more slides because I don't want you all to now think that whatever you are going to build starting from tomorrow. Was there any question? Okay. So I have just 2 more slides on microservices, and it's extremely important slides because I don't want you to walk away from this thinking microservice is the way to go. No, because it comes with some overhead. So one is the operational challenges, which means when it comes to small microservices, you can imagine if you want to have one transaction, one customer coming online to your website and browsing through your catalog, selecting the dresses or the books that they like, adding to the cart, making the payments, entering the address, validating the address, shipping the product, or showing the ordering status, returning the product. All these are going to be done by different microservices. So when there is a customer issue, one customer calls and says, hey, I ordered, I paid $5,000 or sorry, 5,000 rupees or $20, but I got only 4 things. I didn't get the 5th thing. Now, how will you debug? How will your call center or the support team find where the issue is? It's very difficult because you have multiple microservices working together to run the flow. So because of that, microservices ecosystem in production, it's very complicated, and maybe we'll talk about that a little bit later. So there's a lot of logging tools, monitoring tools. You need to have something called trace ID. So if you search with the trace ID, you should be able to track that transaction in the logs all the way from the order or the browsing, catalog browsing till order submission and shipment. Now, I'm not saying it is challenging, but the question is it worth putting so many outside rails if your application is a pretty simple application which is serving as local town? This is the question, and the next slide will give you some idea also how to evaluate that. The BI model solutions, when it comes to data, I told you the data models in the olden worlds is just one table or one database, and that's it. Everything is in the same place. But in the new world, it's all distributed, and this comes with its own challenges. And the third one requires strong DevOps skills, mindset, practice, and everything. Again, we might touch on DevOps later part of this. So there are a lot of, because it's microservices, because it's agile, because it's fast, and because it's getting deployed every night, hundreds and thousands of microservices, there are a lot of tools that is required and associated with it, the DevOps skills. So the people that you need to hire or the people whom you need to train, it is not just development. In the olden days, I hire one C++ developer. He will create the application. He will sit and code 6 months, 1 year, 2 years. He just keep coding in C++. I know some of my friends have always been C++ developers for 5 years, 10 years, mainframe developers for 5 years, 10 years. I had the opportunity to just keep shifting. I always wanted to learn new stuff. So I kept changing my technology. And in today's world, the developer is not just a person who can write code in Java or something else. Again, like my first slide, please don't get scared. If I can do it, you can do it. It's just one skill at a time. So point I'm making is, it's not just writing the line of code, but you as a developer need to also know how you will test this, how you will test it, how will you automate it, how will you deploy to production, how will you monitor in production, how will you find issues? If a customer is complaining my order did not come, how will you go to code and within 2 minutes, 3 minutes, figure out where the code went wrong or where the issue went? So this is where the DevOps skills are needed. And this is why the developers that we hire need to be highly skilled, not just on development, even on others. Again, it's not rocket science. It's very easy to acquire. It's just that you need to systematically invest that time in for yourself. So these are the challenges. But the question is, even with these challenges, is it worth going to microservices? And this is my I think this is my planned last slide. Yeah, this is my planned last slide. Complexity versus productivity. So if you see, for less complex systems, the extra baggage required to manage microservices reduces productivity, which means if you are a very small, let's say in the Calicut city, you are going to build an app which will serve only Calicut city for food delivery app or something like this. You might not want to have this entire complexity of many hundreds of microservices and all those. You might just write a simple waterfall kind of a model you will use, and you'll write a simple application, maybe one file for entire ordering, one file for shipping, another file for back office and things like that. It might be much easier because it's just one application you deploy, that's a done deal. You don't need to worry about the cloud because it's very controllable. In Calicut how many restaurants you will onboard. So you can very well plan next 3 months, I'll onboard 20 restaurants, I'll get the hardware for that, etc. So when the complexity is less, maybe it is worth or it might be worth going for waterfall model. The monolithic, kind of application. But again, if you are very futuristic and you believe you are starting in Calicut, but you have pretty much immediate plan in the next 3 months, 6 months to expand it to Thrissur, into Cochin and everything, I would still ask you to reconsider your decision. So the bottom line is, as the complexity kicks in, as the complexity increases, the monolithic applications reduces the productivity drastically. As you see, the base complexity in the x-axis increases, the productivity decreases. Why? Like I said earlier, when a new developer and when a new employee joins your company, or when a new person joins your team, for him to even understand the application, monolithic application, is going to take many months. And even after understanding, for him to confidently make changes, it's going to take a lot of time, because even if we make a code change in one particular area, he or the team need to test all the modules, because impact can be anywhere. Whereas if you are in the microservices world, when the complexity increases, the productivity doesn't go down, because I can tell that my team, this A team, they will only focus on billing area. My B team will only focus on shipment area. My C team will only focus on ordering area. So they will become an expert in that area. And for me also, I have I have a good risk appetite, because as far as they tested all the use cases in their particular area, I'm confident to put it. So this is the biggest decision factor from going from a monolithic to microservices. But having said that, I would still encourage all of you to kind of read about it if you don't know already, because in the corporate world, especially in the e-commerce area, banking, also the industries like telecom, everyone is moving big time into microservices world. And it's pretty interesting area. If you are passionate about technology, it's very interesting how this area is growing and what are the kind of tools coming, etc. So this is what I have planned, and of course I have a couple of additional topics. Maybe we'll touch upon that 5 minutes, because Amita had told that 5 to 7 minutes question answer should be sufficient time for question answers. But before going there, I just want to take a minute to talk about Amdocs. So Amdocs is one of the leading companies, or I would say the leading company giving software to telecom world, whether it is Airtel's and Ideas in India, or we have customers across the world, 84 countries we have people working, but Canada, US, Europe, Russia, Indonesia, Malaysia, Australia. So we are pretty much in all the countries, and offices there, which means we have citizens from those countries working together. Unlike some of the big companies like Infosys, by the way, great company. I started in Infosys. I have still a lot of respect for Infosys. I was pretty much forced to leave Infosys, because when I had to do my master's from Harvard, Infosys did not have a project in Boston area at that time. So that's when I had to leave Infosys and join Verizon. And I worked for Verizon for 5 years, and unfortunately I had to move back to India because my mom had cancer, and I decided to leave my career in the US and moved back in 2015. My mom passed away eventually, but I'm glad I moved 6 months before that and could spend quality time with her. But then when I moved back, when I had multiple options with me, I chose Amdocs because of the exact same thing that I'm talking about. Yesterday, we got an award from Economic Times. It's the #1 places for women to work, for women employees to work. We got the award. So a lot of focus on the gender diversity, safety at the workplace, etc. And like I said, we are the #1 vendor for the telecom companies. Even if you Google it up, none of our customers are near us. So yeah, again, it's a great opportunity that I could address this forum, and I wanted to talk about microservices and cloud specifically. This place, our official session is over. So in case someone is in a hurry to leave, I know it's evening, but I want, if there are more technology, interested folks on the call, I want to show this 2 items. Just I'm taking this another deck. So DevOps is nothing but, you can see, build. So you start from your plan. So this is the development, this is the operations. In the olden world, like I said, 6 months you do development, 6 months testing, and then you give it to production. Some other team do the operations. It is their headache to do the operation. When I was working for Verizon, there were teams in India, Russia, and all who will develop the code and they give it to us. And then it is our problem to fix their code. And believe me, it is very tough. But now in this DevOps node, it's changed. what happens? We plan the project, write the code, build, compile. I hope you are familiar. Test it, and mostly it is automation. We have a lot of awesome automation tools available, which helps us to avoid 2 months, 3 months of manual testing. Release into the customer site or whatever. Deploy it, which means putting the code in the customer hardware. Operate it means we ourselves, my team is responsible for the operation also. Unlike olden days where it's someone else's problem and I'm sleeping peacefully, someone else is fixing the defect in the night. Now it's my problem. So I better give good software so that it operates well. Operate means making sure there are no customer complaints, etc. And then monitor. I want to make sure whatever SLA that we have given to the customer, X number of transactions within per second, etc. I need to monitor and make sure it is committed, because these days in the contract, if I don't meet that SLA, I need to pay fine. And the beauty is that immediately it comes back to the planning. Means if I see an issue to this, you have one release in 3 months down the line. Every 3 months you release code to production. So if I find an issue today, the customer need to wait for 3 months to get that fixed. Whereas in today's world, as soon as I find the defect or issue, I immediately put into plan, add it to the plan that this is a priority item. And I don't know if you guys are familiar with agile way of working of things. So if not, maybe there was a session in the past. If not, it's worth a session to agile software development practices. So what agile means is there are multiple iterations, and some companies do it like 2 weeks, some 3 weeks. So every 2 weeks, every 3 weeks, you have an opportunity to give a new requirement, which means if I find a problem in production today, I can give that problem to the development team today itself, and I can expect that fix within 2 to 3 weeks. And this is more, bigger companies which are not that agile, but companies like Spotify, companies like Netflix, they can give the fix in the same day. If they put a code, they found some issue, or customers did not like it, or customers are not using that feature because that was not easy to find that option, they can very well change it next day morning. Before you come up, that option would be changed. So that is the beauty of having DevOps. And in each of these stages, like I said, when you come into the IT world, you will hear a lot of jargons, hundreds of tools in each of these areas. Please don't panic. Whichever project you are getting into, you will have a set of tools. Just learn that. Basics are same across the board. Once you learn the basics of some tools, it's easy to go beyond. I'm not going through the definition, and there are benefits and other stuff, but then in the interest of time, I want to go to Docker, the containers, and I think it's very interesting. If you were not listening to me in the last few minutes, because sometimes it gets boring in longer sessions, I think this is a minute you can put back your attention, because this particular item, if you learn, I think it will have value in your day-to-day or career in this IT world. Docker, I don't know if you have heard about Docker images, the new way of building and delivering software. So let me show you, what are containers. Docker containers is what we call. So today in the software world, we call something called containers, and we deploy container. We do not deploy individual softwares. So you can see a container here. You have Linux, you have Java, Tomcat, Spring Cloud, and Amdocs application. So this entire thing is container. In the past, it was different. You had to install Linux separately. You had to install Java. I told you, right, when we used to, I was responsible for even procuring hardware back in the US Verizon. Once I get the hardware, someone need to come and plug in the hardware, the power up, boot up, install the operating system. Then, one by one, all these third-party Tomcast and Spring Cloud and all this, install one by one. Then you install the applications. It was a very tedious process, weeks. But now in today's world, you build the application, you install all this software once, create an image, a container, an image, and you can spawn that hundreds of instances within seconds. So you don't need to install in each and every hardware. And this is why companies like Amazon is able to provide cloud services, because there's no individual installation. You just deploy the container. Everything that is needed by Amdocs application or your application to run in an ecosystem is packaged together, so that you can just package that in any hardware. You don't need to worry about the compatibility and everything. Now, the example that I wanted your focus on is this. In the past, I'm just comparing this in the shipping industry. In the past few years back, in the shipping world, when you are sending stuff abroad, this is how they used to pack. Okay, and you can see it is not very efficient, and plus it's not very safe. Your things are not very safe. It can get mixed up, it can get broken, etc. And there's a limit to which you can load, because you cannot keep loading on top and top, right? And how is it done today? And this is how we used to give software in the past. Back in 2000s and 2005, 2008, I send hundreds of files abroad. I zip the files and send it to the US and to UK. and those people will unzip the file, try to deploy, then say, hey, this is missing, that is missing, this configuration is missing. It was a nightmare. The deployment used to be entire night and whole week we used to stabilize. And how is it today? This is container, and even in the shipping world, this is container, right? So when I moved back from the US to India, I booked a container, and that container was brought to my house, kept it outside my house, and then I brought a ship. There was a packing company who came. They packed all my stuff, all the things that I wanted to bring back to India, my TV, furniture, my dresses, boxes, everything they packed, and they put it into the container, and they logged it and gave the key to me, which means no one else can open that container. So I'm very confident that it is safe and it's packed very well because I packed it. No one is going to touch until delivery at my doorstep back in Pune. And it is very easy for the shipping company to load as well, because for me, I needed one full container. But if there is a small, if you are importing something and someone needs like a 1/4 of a container, you can book that, and that can be a separate box that will be packed into a particular container that you are seeing. So overall, we were able to package more, and it is more safer also, or it is more intact when it reaches the destination. So connecting to today's world, when I package my software in India, I will put my operating system, third-party tools, my database, my application code and everything. I'll make sure it is running in a particular environment. I package it as a container and I give it out. And that can be deployed in US, UK, anyone can deploy it. Nothing is changing because exactly what I built is what they are getting. And this is what the new container world and the deployment world. So I think, there are a lot of new stuff coming, and, it's like a 2-day program to talk about all that. But I just wanted to expose you all to this. That's it pretty much. We have 6 minutes. If there is any questions, we can move to that.
Thank you, sir, for this amazing and informative session. So attendees, if you have any queries related to this topic, you can directly ask sir, or either you can write it down in the chat box. It will be read out. So any questions? So there is one.
I see the question. So just go to Google and let me do it right away as we speak. I'm going to Google and let me go to. I prefer AWS because I'm. Believe me, I don't have any commission from them. But since I'm an AWS certified architect, I can guarantee you that the courses that they have is awesome. So I'm just going online, aws.amazon.com. Okay, and just go there. Advertising, financial services. You have different industries there. But let me search. If there are other questions, please feel free to put in the chat while I look this up. I'm searching AWS certification in Google. Yeah. So let me put in the chat. And again, I don't know if you're a student or if you're working somewhere. If you're working, most of the companies are sponsoring certifications, learning, etc. There are very good, in the website itself, it's given a lot of reference materials are there. If you search online also, there are a lot of free courses. There are paid courses. Depending on whether your academic sponsor or company will sponsor, you can choose which one. But believe me, I've checked out both, and even with free courses, you can clear the certification. So my suggestion is, okay, you're a first year student. Okay. So just if you do not have a sponsor, just go through all the free materials available. On the site also, there are some free courses. That's a good start. And if you are interested, after checking it out, if you're really interested in that, I would say it's worth investing. Spend some money from your, pocket money, I would say. Spend some on this, it will be worth it. Because this is where the world is going. And by the time you will hit the industry, this will be much more large scale. Cloud knowledge is important. And during the campus interviews and outside campus, if you are able to tell them that you have cloud certification, you have knowledge about the campus, believe me, it's going to make a big difference in your hiring. And if you get hired right into the right place, then it will be very easy to continue in that space. When I started my career, I was put in my mainframes, because in those days there was no choice. Some people were in Java, some in .NET, some in mainframes, and mainframes was least sexy, so to speak. But I didn't crib. I learned that. I spent 2 hours continuously, because nothing is bad. Everything has its own learning. So now that I know mainframes, I know why this new stuff is different from that, and I'm able to connect the old world and the new world. So whatever is thrown up to you, even in your college curriculum, don't always be disappointed that you are not getting to learn microservices and cloud. There's a reason for that, because I'm able to speak about things because I know the basics. So in college curriculum, generally they teach you the basics. So don't lose interest. Learn that very well, because that's going to help you to switch from one technology to another technology, or one tool to another technology. If your basics are not clear, whatever you learn, the advanced topics, that will be just, we will know you are just a theoretical person and not a practical guy. Wish you all the best. And I would say, whenever, especially with this pandemic situation, we have a lot of time. I would say invest time on this. Anything else? Any other questions? Okay, I hope it was helpful. You can hit me up on LinkedIn, Roshik Mohamed itself. You search Roshik Mohamed, Amdocs, feel free to connect. Also, in case you have any queries on the topics that we discussed or others, feel free to connect on the career planning and everything. Amita, Priyanka, Sabik sir, and the entire team behind this event, thanks for the opportunity, and wish you all the best. Many more successful sessions. You guys are doing a great job. Thank you.
So actually, I have a question.
Sure, Vinu.
Okay.
There's a video on Traversary Media in YouTube about Dockerization and containerization. Will it be the best practice to start with the DevOps?
So Vinu, if you go, I don't know which one you're referring to. So please hit me up on LinkedIn. Just send me a message. Tell that you had attended my session, and we can continue there. Maybe I can also look up and give you some good reference. By the way, I have to tell you. By the way, I have to tell you, it's very interesting. I'm dealing for last 20 years generally with the corporate world, and of course, when I hire graduates, of course, my managers and directors board them. But having a direct interaction with students, it's very uneasy to hear the word sir. I should have corrected it from the start of the session, but I apologize. I feel very awkward when you guys call sir. So even in future, if you end up connecting, please address me as Roshik and not sir, please. Yeah, that's it, I think, for now. Priyanka, over to you.
Okay, so before we wind up the session, I call upon Mrs. Amita Junaina TK, IEEE SB Counselor, KMCT College of Engineering, to render her vote of thanks.
Good evening, all. With great pleasure, I would like to thank our guest speaker, Mr. Roshik Mohamed, who had readily accepted our invitation and joined us today for this wonderful talk on the topic product development in microservices and cloud. Thank you, Roshik. And as the counselor of Student Branch of KMCT CE, it's an honor to be a part of the Thursday webinar series conducted by IEEE Malabar Subsection and IEEE Malabar Hub. Thank you, Sabik sir, for giving us this opportunity. I would also like to thank all the participants and student members who have joined us today. And thanks to Priyanka, who had supported us in all the way. And thanks to all for joining us. Thank you all.